Good morning, sir.
Good morning, Nana.
Good morning, sir.
Very good morning. Good morning.
Good morning, sir.
Good morning, Nana. మార్క్స్ ఇంకా రాలేదు కదా నాన్న? వచ్చాయా? Got the marks, Nana?
Yes, sir.
Yes, sir.
Okay. Was the list there in the group?
No, sir.
No, sir. After 3 days.
Okay. So, nitrogen metabolism. Then we have a small account of respiration. And that too, it is for next Sunday's exam, right?
Good morning, sir.
Very good morning, Nana. Shall we proceed, Nana? Shall we start? Came all? 58 are there, I think few more. It's okay, we'll start.
Sir, we can't see that portion.
Muted? Okay, 1 minute. Yeah. Is it okay now? Is it okay now?
No, sir.
Acha, camera. No, audibility is okay, no?
Yes, sir.
I think now it's okay. Okay, Nana?
Yes.
Yeah. So nitrogen metabolism. special emphasis is made on nitrogen metabolism. You can ask a question, why not carbon metabolism, hydrogen metabolism, oxygen metabolism? Because it is so important, and the speciality of it is plenty in the atmosphere, Nana, in the form of molecular nitrogen. But for most higher plants, that is not a usable form unless it is converted into usable forms. That is the thing. That's why it is so important. So next to carbon, hydrogen, oxygen. Nitrogen is abundant in living organisms, not only plants, in plants and other organisms. Our concern here, of course, is more from plants life point of view. Next to carbon, hydrogen, oxygen. Abundant element is nitrogen. Though it occurs more in the atmosphere, but not a usable form. In the atmosphere, it accounts for how much percentage among all, Nana, by volume? It accounts for 78% of gases by volume. 78%. So highest in amount in the atmosphere it is. Next highest is what, Nana? Next highest in the atmosphere is, there can be questions.
Oxygen, sir.
In atmosphere is oxygen, which is about 21%. So oxygen can be taken as second abundant element of atmosphere. That is second abundant element of atmosphere. That we know it. See, Nana, 78 plus 21, 99% gone. Remaining 1% only other gases. Among them, how much is carbon dioxide percentage, Nana? 0.03. So less. But do plants face the problem of CO2 availability? Never. Least in amount, but never a problem to the plants. In fact, problem is excess CO2 nowadays in the atmosphere. Reason is that CO2 as it is can be used by the plants. But this nitrogen, which is in the atmosphere, not a usable form. Nitrogen of atmosphere is molecular nitrogen or dinitrogen. Molecular nitrogen or dinitrogen. Oblique better be right, which is otherwise called dinitrogen. And conversion of this dinitrogen into usable form is nitrogen fixation. Conversion of molecular nitrogen into usable form. Tell me, Nana, what is the usable form? That is mostly nitrates, we know. To some extent nitrites, to some extent ammonium ions or ammonia. Okay? Most of the plants cannot do this conversion because this conversion requires the break of the so-called strongest bonds between the nitrogen atoms. They are considered as strongest triple covalent bond. Most higher plants cannot cause nitrogen fixation because it is difficult to break the strongest covalent triple bond between two nitrogen atoms. Then who can do that? Only enzyme nitrogenase can do that conversion. So these are considered strongest covalent bonds now. Nitrogenase enzyme can cause this, but that is there mostly in microbes. Nitrogenase is the only enzyme that breaks triple bonds, capable of breaking triple bond and convert into usable form. That is ammonia or ammonium ions. Which then convert into nitrate, that's a different thing. However, most higher plants cannot do this nitrogen fixation. The microbes, especially some prokaryotes, like bacteria, what else, Nana? Cyanobacteria, have nitrogenase. Therefore, higher plants depend on them for nitrogen fixation. This is all the introductory part about nitrogen and why more emphasis is being made on nitrogen, why it is studied separately under heading nitrogen metabolism, to just realize that. That is the problem with nitrogen, though it is plenty in the atmosphere. In nitrogen, in nature, if you take, nitrogen occurs in different forms and in a state of flux, moving from one form into another, which is involving an altogether of 5 events which will cause bioremediation or biogeochemical cycle, we call it. That is now studied under the heading nitrogen cycle. Among higher plants, those which can take atmospheric nitrogen or which higher plants, Nana? In symbiotic association with the nitrogen fixing microbes. Higher plants in symbiotic association with nitrogen fixing microbes can make use of atmospheric nitrogen. Otherwise, no. And which higher plants were they, Nana? Mostly leguminous plants. Due to symbiotic association with nitrogen fixing bacterium. What was that nitrogen fixing bacterium, Nana? Bacterium.
Rhizobium.
Yeah, in the root nodules. are able to use atmospheric nitrogen. Molecular nitrogen, that is dinitrogen. Not to repeat, nitrogen is a structural element of which organic compounds, because you are already aware of. Can you tell me, Nana? It is a structural
Yeah.
of amino acids. Once it is there in amino acids, proteins, enzymes, we have it. It was also a structural element of nitrogen base. Once it is there, it can be in nucleotides, means it is in nucleic acids. In addition, it is also there in chlorophyll pigments. It is also there in hormones. It is also there in vitamins, isn't it? Nitrogen, but I have mentioned, Anna, is structural element of many organic compounds, many biomolecules. It is again listing them. So it is relisting, like amino acids. Once it is so, proteins. Once it is so, enzymes. Also, nitrogen bases, the purines and pyrimidines. Once it is so, nucleotides. Once it is so, nucleic acids. Also, chlorophylls of various types. Also, alkaloids of various types. Also, hormones of various types, etc. Vitamins also. Now coming to the point. Nitrogen in nature occurs in different forms at different places. So better is put the heading nitrogen cycle. So nitrogen in nature undergoes top line మొత్తం వస్తుందన్న ఓకే biogeochemical cycle. And occurs in different forms at different places. Different forms in different places. It is in a state of flux, moving. What does flux mean, Nana? Moving. Moving inward the cell, influx, out of the cell, efflux, and it is between the different compounds. It is in a state of flux between different forms of aid. That is molecular nitrogen in atmosphere, ammonia in the soil, biomolecules in organisms, okay, Nana? Can I rub up this part, Nana?
Yes.
See, it is in a state of flux, moving between different forms like molecular nitrogen, which is there in the atmosphere. It is brought into the soil as ammonia or ammonium ions. It will become part of biomolecules. When it is part of biomolecules, it is in the organisms. It can also be like nitrates, nitrites. In atmosphere to some extent, and soil. Yes, Nana? So keeps on moving from one form into another, but bulk is where, Nana? This is bulk. Bulk form. and which is converted into these forms to be utilized by the organisms. So this flux involves 5 events which are together called nitrogen cycle. So when it is undergoing conversions from one form into another, so this flux involves, this moving from one form into another involves about 5 events. That is 1. Nitrogen fixation. 2. Assimilation, fixed to be used in the body of the organism, especially in plants. Then, after death of the organism, the assimilated should be again converted back into ammonia called ammonification. Meanwhile, also undergoes conversion into nitrates called nitrification. And of course, brought from atmosphere should also go back into atmosphere to maintain the required proportions at all these places. That is reversal of nitrogen fixation, which we call it denitrification. So this flux involves about 5 events: nitrogen fixation, assimilation, ammonification, nitrification, denitrification. All these events together represent what, Nana?
Nitrogen cycle.
Nitrogen cycle, because it is cyclic manner. Nitrogen brought from atmosphere is okay, but should be released back again into atmosphere, denitrification. So all these together called nitrogen cycle. All these events together form or represent nitrogen cycle. So first we draw the nitrogen cycle and discuss the events one by one in detail. Who is doing nitrogen fixation, who is doing assimilation, who is doing ammonification, nitrification, denitrification. All these is to be seen. Step 1 itself is time consuming for us, Nana. It is important. There is so much to be remembered in that also, to be memorized, but won't be a problem to you. Many of them you already came across.
Yes, sir.
So go to full scale page, Nana, to draw the cycle. From board exam point of view also it is important.
So 1 minute.
Okay. For drawing the cycle, go to full scale page. Okay, I think this part to rub off.
Okay.
So like I'm doing on the board, We take the full scape, at least half a page if it is a long notebook. Half page it requires if it is long notebook. Let us take this is atmosphere. So, in the atmosphere, we know much of it is molecular nitrogen, dinitrogen. Okay. From the atmosphere, that is in the form of molecular nitrogen, which can be there as gas to some extent in the soil also. Because we know any element can undergo simple diffusion from its high to its low. So soil spaces, suppose if you take on the soil in the atmosphere wise, close to the soil, it will be bulk. But that is molecular nitrogen, dinitrogen form. So what was the first step, Nana? Nitrogen fixation. This nitrogen fixation, okay, can be of different types, like biological nitrogen fixation. One. Within the nitrogen fixation, subtypes. So let us take this as biological. Which converts nitrogen into ammonia. Even industrial also, there is a mechanism to convert this, that is called industrial nitrogen fixation. Also into this. So this is industrial. Biological nitrogen fixation, industrial nitrogen fixation. Physical nitrogen fixation there, that makes available slightly in a different form, that is nitrates, which will be physical nitrogen fixation, that is during thunderstorms. So we call it as physical nitrogen fixation. Can be physical nitrogen fixation during one, thunderstorms. Estimate thunderstorms which bring usable form of nitrogen to the soil, and thunderstorms followed by what now? Lightning. Thunderstorms, lightning, convert this into this. Also made available in this form from industrial combustions, which also we take it as physical, because they are not involving organisms. Even forest fire, even emissions from automobiles, etc. I'm writing, we go in detail afterwards. That is physical nitrogen fixation. So this was step one, nitrogen fixation. This fixed nitrogen, what it should undergo, Nana? Absorbed by the root system of the plant. So in the plants means in the organisms. So these are all usable forms we take. So literally you take it as in the soil now. This is brought to the soil.
Yes, sir.
Okay. Once it is brought to the soil, absorbed by the root system of the plant. So in plants, this will undergo assimilation. In plants. So this is second event. Number one, nitrogen fixation. Within that, different types. So number two, nitrogen assimilation in plants. So making use of these forms in biomolecules formation like amino acids, proteins, etc. Assimilation in plants to form amino acids, proteins, etc. And from the plants, naturally, it will go into whom, Nana? Animals. And death of plants and animals. Result in what? Biomass. Death of them, plants and animals. So dead bodies, literally. From the dead bodies, with the help of microbes, the third event you see here, that is ammonification, we call it. Conversion of nitrogenous materials like amino acids, proteins from dead bodies into ammonia. What is this step called, Nana? Step 3, ammonification. This was assimilation. So step 3 is ammonification. Tell me now, what does ammonification mean? Conversion of nitrogenous compounds into ammonia. That is amino acids, proteins, etc. into ammonia. Ammonification. Then step 4 is here. You are going to see which happens in the soil. So nitrification. Tell me now, what does nitrification mean? Conversion of ammonia into nitrates is nitrification. Fourth step. See how in a continuous state of moving between different forms in nature.
Sir,
All these come under in the soil. Yes, tell me, Nana.
sir, during assimilation, nitrate turns into nitrogen.
So that is a deep, a big story, Nana. We'll discuss better. Wait. That itself is a big process. See, the wonder here is plants can absorb this form easily. But this form straight away cannot be used in proteins amino acids. This should be converted back into ammonia in the plant, then will be used in amino acids formation. You know, amino acids contain an amino group. Remember biomolecules? An amino acid,
Yes, sir.
a hydrogen, a carboxyl, an amino group, and an R group. So it should form amino acid. And you know what are proteins? They are polymers of amino acids. Got it, Nana?
Yes, sir.
Yes,
This
sir.
is they can absorb nitrates, but they ultimately need this form to be used in assimilation process. So that should again undergo conversion into this, which we call it reduction. And that's where the enzyme nitrate reductase. Have you heard about the enzyme nitrate reductase? Metal ion cofactor of it was molybdenum.
Yes, sir.
So death of plants, animals, which form detritus, ammonification. Then nitrification, which is also by the microbes. This all is events in the soil, of course, you know it. Then fifth is, guess and tell me, Nana, what should be the fifth? We brought from atmosphere, but how is it?
Denitrification.
Released back into atmosphere. That is denitrification, the fifth event. This form goes back into atmosphere. See, brought from atmosphere, the same way should be released back into atmosphere.
So what is the third event?
Yes, Nana?
What is the third event, sir?
Ammonification, Nana. I think I wrote in red. That is the problem.
Thank you, sir.
First was nitrogen fixation. So it should again go back into. That's why we say nitrogen in the atmosphere is 78%. When it is fixed by the plants, how can it be 78 there? Again released. Meanwhile, it is doing so much in the organism. Organisms taking that nitrogen for their growth, reproduction, etc. And once they die, they release back into the atmosphere as a gratitude to the atmosphere. Taken from atmosphere should be released into atmosphere. So the fifth, the last event is denitrification. So all these we are going to discuss one by one. First, we confine to nitrogen fixation. Bulk of the nitrogen fixation is actually biological, and about 70% of nitrogen fixation is by biological, and that too by rhizobium of root nodules of legumes. So leguminous plants so significant in nature. That is the reason why leguminous plant produce is rich in proteins, and bulk of proteins is nitrogen. In order to get nitrogen only, what the insectivorous plants were doing, Nana? They were feeding on insects. Why were they feeding on insects? Because insects are rich in proteins. And proteins are rich in nitrogen. To overcome the problem of nitrogen, insectivorous plants which do not have root nodules have adopted a different strategy. That's why they were called partially heterotrophic. For the denitrification, the arrow in the textbook is shown towards that side and this side also. Nana. And as you go by this sentence, Nana, logic, if you go, denitrification should be taken as reverse of nitrification, isn't it? But is it reverse of nitrification, Nana? It is reverse of nitrogen fixation. I don't know why is this interpreted that way. When nitrification is ammonia into nitrates, denitrification should be nitrates into ammonia, but it is not so. That will be called reduction, which we see under assimilation. And another surprise is plants can take only that form, but this form is usable. How means by converting it into that form they take. Some can take as it is this form also, but mostly they take that form. In whatever the form they take, ultimately they need is this form inside them. So even if they have taken that form bulk, which will be converted back into this and then will be used in assimilation. See how the things go on. When this can be used straight away in metabolism, why this should be converted into that, then taken up, then again converted into this is the question. It's all the adjustments in the nature now. For organisms, for their survival, for their growth and reproduction, they are making use of these elements of nature. So they are taking them from the nature and releasing back into the nature. Meanwhile, they are carrying out so many things, the growth, the reproduction. Some amount of nitrogen always will be there in the living organism. Some always there in the soil. Some always there in atmosphere. And these conversions will go on taking place continuously bio-geochemical cycle. Done all of you, Nana?
Yes, sir.
Okay. Now, subheading 1, nitrogen fixation. We already discussed as to what is nitrogen fixation. It is conversion of molecular nitrogen, that is dinitrogen, into usable form. That is ammonia, ammonium ions, nitrates. It can also be in the form of nitrites, but mainly was which one, Nana? nitrates form the mainly usable form. So what all it may be? It involves break of triple bonds. It involves break of triple bond. What is the speciality of this triple covalent bond, Nana?
Strong.
Considered as one of the strongest bonds. One of strongest bonds. This is mostly done by nitrogenase if it is in the living organisms, but physical nitrogen fixation also there, which occurs and makes available of nitrates. So nitrogen fixation is two types. A, physical nitrogen fixation. B, biological nitrogen fixation. Subheading A, physical nitrogen fixation. Occurs mainly during thunderstorms and lightning. That involves electric discharge. Therefore, also called electrical, it is. Therefore, also called electrical nitrogen fixation. When electric discharge occurs, it undergoes oxidation added with atmospheric oxygen. So these steps involve number one. Or we take this, it occurs in 4 steps and altogether. This will occur, this one occurs in 4 steps. So stepwise, number one, added with oxygen, you get nitric oxide. N2, on oxidation in atmosphere, in the energy is from electric discharge.
Sir, time completed, sir.
Time అయిపోయిందా నాన్న? Okay. Yeah, with this step I'll finish up. ఎంత అయింది? 9:01. Okay. Just 1 minute more. Next step, what happens? 2NO, further oxidation will form 2NO2. What is this, Nana? nitrogen dioxide. This because thunderstorms followed by rainfall, precipitation, right? So the same two molecules of NO2 combine with rainwater to form nitrous or nitric acid. HNO2 or HNO3. You know, HNO2 is nitrous acid, HNO3 is nitric acid. These, on reaching soil, naturally, along with rainfall, reaching soil, combines with alkali radicals. On reaching soil, combines with alkali radicals like potassium, calcium to form their nitrates, which are usable form. Their nitrates means calcium nitrate, potassium nitrate, or potassium nitrate. Then what happens, Nana? Goes into root system of the plant. So can be taken up by the roots of plants. So rainfall never to be underestimated, Nana. It is also making available of some amount of nitrogen, usable form of nitrogen. Because this is happening in the soil, on reaching the soil, combines with alkali radicals. Okay, Nana? So that is fourth step. We take it as D. Got it? Understood, Nana? So we
Yes,
can
sir. Yes, sir.
tomorrow, no problem.
Thank you, sir. Bye.
Bye, Nana. See you tomorrow. All the best.